Welcome to my last set of videos for Calc 3. In these videos, we'll talk about what is arguably my favorite theorem in mathematics, Stokes' theorem. Now, of course, Stokes' theorem is actually a much more general statement than what we'll talk about here. And in fact, in this class, we've already studied two forms of it, which is the fundamental theorem of line integrals and Green's theorem. And in the next section of videos, you'll study yet one more, but this is the one that bears the name of the general theorem. So let's talk a little bit about it. But before we can do that, we need to define orientation on the boundary of a surface. So let's do this. Let S be a surface with orientation given by n, right? And suppose S has boundary, which we'll call C, right? So let's change up that sentence a little bit, right? So what does that look like? Well, it might look something like this. So let's say here's the surface. Let's draw in the boundary here. So C is the green part, is the boundary, right? Then we have S up here, right? And again, S. Right, so let's say that's our surface, right? It's this kind of like, well, just for a generic drawing, it's this kind of half bean-shaped thing. All right, and let's draw the orientation on S. Right, so an orientation on S looks something like this, maybe. Right, so it's a unit normal vector field, okay? All right, so we can ask, what kind of orientation does the surface S induce on its boundary, the curve C, right? So think back to when we were talking about Green's theorem, right? We asked that the boundary of the region be positively oriented, which in that case meant that when we walk around the surface, or when we walked around the planar region, it should be on our left, right? Okay, well, what does that mean here? Well, it's a little ambiguous here because there's two sides to the surface. There's kind of this outside part, and then there's the inside part. So you could ask, well, what does it mean then to be positively oriented, or to induce an orientation on the boundary? Well, the way we think about it is we walk along the boundary of C, and we walk on the side of the surface S where our head points in the same direction as these normal vectors, right? And then we say that the surface should be on our left, right? So which way do we have to walk around this curve C? Well, so we're walking along it here, and our head is pointing in the direction of these normal vectors. So for you here, if you're walking along this piece, your head would be coming out of the screen, right? So should I walk that way or that way to have the surface on my left-hand side? Think about that for a second. All right. So you should figure out that we have to go this way, right? So let's give this sort of an official terminology here, right? So we say, sorry, not S, but C. We say C has orientation. So C has orientation consistent with S if if while, so this will be a little kind of informal of a definition, but it should make sense. So if while traversing C with your head in the direction of N, right? The surface S is on your left side, right? So there is actually a mathematically sort of rigorous definition of this, but it involves something that we're not really going to talk about in this class, so we'll leave it off. But if you're really curious, I encourage you to go look up either online or look in a book on differential geometry or something like that about how a surface induces an orientation on its boundary. Okay? So speaking of what I just said, so we say, in this sense, right, we say S induces, so actually let me add up here, in this sense, this meaning this, right? Right, so we say S induces an orientation on C, right? And C, with this orientation, is denoted by boundary of S, right? So this will just give us kind of a shorthand way to say, yeah, it has that orientation, okay? All right, so hopefully that makes sense. I know this can be a bit tricky to think about, but if you got used to Green's theorem and how the orientation happens on the boundary, I'm sure you'll have no problems with this. All right, so just try and think about a few examples, and see you in the next video.